Introduction to matrices, types of matrices, and algebra of matrices. Introduction to matrices. A matrix is a rectangular arrangement of numbers, elements in rows and columns. It is usually denoted by capital letters like A, B, C, etc. If a matrix has m rows and n columns, it is called an m into n matrix. Read as m by n matrix. Example: A equal to, this matrix you can see here is a 2 into 3 matrix because here is 2 rows and 1, 2 and 3 columns. You know, first point is m. M is number of rows. Number of rows is 2. Now what is the n? N is the number of columns. You can see here 1, 2 and 3. So this matrix is 2 multiplied by 3 matrix. It means the order is 2 into 3. Types of matrices. Now you can see here type, definitions, example. Row matrix are matrix with only one row. You can see here in a row form. Column matrix are matrix with only one column. This is a column types of matrix. Square matrix, same number of rows and columns. Now this matrix is 2 into 2, maybe 3 into 3, 4 into 4, because this is a square matrix. Diagonal matrix, a square matrix where all of diagonal elements are 0. Now you can see here is given diagonal elements and all other elements are 0. That is called a diagonal matrix. Scalar matrix, a diagonal matrix with equal diagonal elements. Equal diagonal elements. Here is 5, here is also 5. If here is 25, then must be 25. That is called a scalar matrix. In a scalar matrix, every diagonal elements must be same. If here is given 10, then here is also 10. Then you can say this is a scalar matrix and all other elements will be 0. Identity matrix, a square matrix with 1 on the diagonal and zeros elsewhere. You can see here a simple wording is given, identity matrix. A square matrix with first on the diagonal and zeros elsewhere. It means in all the diagonal element must be 1 and other element is 0. That is called identity matrix. Zero or null matrix, all elements are 0. All elements are 0, that is 0 matrix, maybe null matrix. Symmetric matrix, A equal to A transpose. Transpose is equal to original matrix. That is called a symmetric matrix. You can say here, you can convert in transpose form. Skew symmetric matrix, A equal to minus A transpose. This is a condition of skew symmetric matrix. You must be remember all types of matrix. Algebra of matrices. Matrix addition. Matrices must be of the same order. This is very important. Matrices must be of the same order, then addition possible. 8 corresponding elements. You can see here this matrix is 2 by 2 and this matrix is also 2 by 2. Matrix A and matrix B. We add both matrix. Now here is given 1, here is given 5. 5 plus 1 we get 6. Now 2 plus 6 we get 8 because here is given plus sign. We add both matrix. Now 3 plus 7 equal to 10. 4 plus 8 equal to 12. We add, this is addition of matrix. Matrix subtraction. Same as addition but subtract corresponding elements. A minus B equal to minus 4, minus 4, minus 4, minus 4. Element of A minus element of B, we get this answer. You solve step by steps. Scalar multiplication. Multiply each element of the matrix by the scalar. A equal to, you can see here that 2 multiplied by matrix A, then we get this answer. Matrix multiplication. You must be remember this. Possible if the number of columns in the first matrix equals the number of rows in the second matrix. Use dot product of rows and columns. Matrix A equal to 1, 2. Matrix B equal to 3, 4. You know what is the conditions? The number of column of first matrix. It means 1 and 2. And equal the number of rows in the second matrix. Row is 1 and 2. It means multiplication is possible. Now AB, it means we will find multiplication of AB. Now 1 multiplied by 3, you can see here. Then we write plus sign. 2 multiplied by 4. 2 multiplied by 4. It means 3 ones are 3 plus 2 fours are 8. Then we add. We get 11. This is simple multiplication of matrix. Transpose of a matrix. Flip the matrix over its diagonal. A equal to, you can see here this matrix implies that A transpose equal to, now this row, you can see this row convert in column and this row convert in this column. Then we get A transpose matrix. Properties of matrix algebra. Associative. A plus B plus C equal to A plus bracket B plus C. This is associative property of matrix. Commutative property. A plus B equal to B plus A. Not true for multiplication. Distributive, you can see here A bracket B plus C bracket equal to AB plus AC. Transpose, AB transpose equal to B transpose A transpose. Thank you.